This is the last kind of formal lecture of the day. We're going to have our guest lecturers next, who are going to talk about really exciting parts of their workflow and problems that they've found. But this is the last part of the regular curriculum. And so the last thing we wanted to talk about today is to talk about machine learning teams. And so, actually, if I could just get a quick show of hands, how many of you are kind of looking for jobs right now, or think you might change jobs at some point and want to hear more about like the machine learning job market? Okay, it seems like maybe a third. How many people are sort of hiring or looking to build a team? All right, it's about even. I thought I saw some people raise hands for both, which is like seems a little weird. Are you starting a startup? I don't know. But regardless, I'll talk about both. And so the things I want to cover here are, just to set the stage a little bit for the rest of what I'll discuss. I'm going to talk about the AI talent gap and kind of why hiring and looking for jobs in this space is so hard right now. And then I'll talk a little bit about the different machine learning related roles that we've seen, and then how those roles are composed into teams in the companies that we've talked to. And then I'll say a few things about the hiring process, and finally I'll touch a little bit on the exam for this course, which is related because it's a way to help you prepare if you're looking to go into interviews soon. So the AI talent gap, it started from this question of like, how many people are there out there that really know how to build AI systems? And I looked for estimates on this, and there are a few different estimates. And so the lowest estimate I saw is 5,000. And this is from Element AI a few years ago. And so this is like the number of people that they thought were actively publishing research in, I think, 2016. And then in the same report, they estimated that there are 10,000 people that had the right skill set. In a different report, Bloomberg estimated that maybe there's 22,000. Those are people who are PhD-educated AI researchers, which as we all know, not everyone who can do AI has a PhD, so maybe this is an underestimate. A higher estimate that I saw was 90,000, which is Element AI's guess as to the upper bound to the number of people. And then kind of the highest number I saw was around 200 to 300,000, which is a number that Tencent estimated. And so, so that's kind of like looking at the number of AI developers broadly. And so you might think like, is this a large number or a small number? Well, there's 3.6 million software developers in the US alone, right? So the number of people who kind of have an AI skill set seems to be like orders of magnitude smaller than that. And that number is 18.2 million when you look at the whole world. And so the challenge that this presents is that what this means in practice is that we see often like a very fierce competition for AI talent. And in the course of the interviews that we did to develop this course, we heard a few kind of interesting quotes. This is actually from an article by Jeremy Kahn. Everyone agrees that the competition to hire people is intense. And academic conferences are turning into these frenzied meat markets where like corporate recruiters are, and salaries are being driven up. And as someone who's been to a bunch of machine learning conferences, I can say that this rings true to me. Like they have started to feel like entirely a recruiting pitch. A quote that we heard from a computer vision engineer: hiring is crazy right now. It's a young field that got popular very quickly. Lots of demand, not a lot of supply. Hiring for ML is very challenging and takes way more time and effort than we expected from a startup founder. And so this is just kind of to give you a sense of how people on the hiring side have been thinking about how hard this problem is, of like finding really good machine learning engineers to work on their problems. And so as an implication of that, there's kind of a lot of things that you might do differently if you're looking for a machine learning job than if you're just looking for a regular software engineering job. And I'll talk about that a little bit later. But first, I want to just quickly go into what are some of the machine learning related roles that you might see at companies. And so a few of them are, there's DevOps, there's roles like data engineer, there's roles like machine learning engineer, machine learning researcher, and data scientist. And so how can you make sense of all of these different roles, and what's the difference between them? So breaking it down a little bit, starting with DevOps engineer, typically what DevOps engineers do is they deploy and monitor production systems. And so the work product that they're producing as a result of their job is a deployed product. And the tools that they're using are maybe AWS Lambda or some other deployment tools. Data engineers are usually responsible for building data pipelines, aggregating data, storing data, monitoring data. And their work product is often like a distributed system that allows you to kind of quickly access data for training. And so they're using things like Hadoop and Airflow as part of their regular workflow. Then there's machine learning engineers. And machine learning engineers are typically tasked with training and deploying prediction models. And so their work product is a prediction system, and often it's a prediction system that's working on real data in production. And so these people are kind of bridging the gap between training machine learning models and being able to deploy them. Then there's machine learning researchers who, the distinction between machine learning researcher and machine learning engineer is fuzzy in a lot of organizations. But typically, machine learning researchers are only responsible for the training prediction models piece. And then they hand off the model that they train to someone like a machine learning engineer to deploy it into production. And there's a lot more of this is around kind of exploration of data and iteration and research, as opposed to getting things in the hands of customers. And then finally, there's this role of data scientist. And this one is particularly nebulous because, as far as I can tell, no one actually agrees on what a data scientist really is. And so I've heard this used to describe all of these things above, as well as many other things. In many organizations, a data scientist is like someone who knows how to use Excel. And in a lot of organizations, it's kind of someone who knows how to use Excel and also databases and train simple machine learning models to answer kind of business questions and write reports and communicate the results up to management. But also in some organizations, the role of data scientist really means something more like machine learning researcher or machine learning engineer. So what skills do you need to actually do each of these jobs? So on this chart, the left axis is kind of level of software engineering skill, and the bottom axis is level of machine learning knowledge. And then each of the roles is plotted on this 2x2, and the size of the bubble corresponds to kind of how much communication and technical writing acumen you really need to be successful in this role. So starting with ML DevOps, this is basically a software engineering role. And often these people just come from standard software engineering pipeline, and they're just kind of placed on a machine learning team. Data engineers, the most common arrangement that we've seen is that these folks are software engineers, and the machine learning team is their customer, but they're also sometimes embedded in the machine learning team. Machine learning engineer is according to a lot of people that we talk to, is kind of like a rare unicorn type role to hire for, because it requires a very rare mix of actually deeply understanding machine learning and being able to train state-of-the-art models, but then also enough engineering skill to be able to make those models work with the rest of the code base and the workflow of the company. And so many people told us that this is actually the hardest role to hire for. And so one thing that we've seen is that there's a pretty wide range of backgrounds that perform this role. And some common ones are software engineers who have spent a lot of time self-learning machine learning, or often it's also science or engineering PhDs, but maybe not machine learning PhDs who have worked as software engineers for a while. Machine learning researchers, this is typically your ML expert. And the most common background here is still a master's degree or PhD in CS or stats. But what's becoming increasingly common is to see people who have gone through the Google Brain Fellowship or the Facebook Fellowship and move into a role like this. And sometimes you also do see people transition from more typical software engineering roles. And then lastly, data scientists, since this is kind of a catch-all term, this can mean basically anything. There are people coming straight from undergrad. There are degree programs in data science now. But then sometimes these folks are also astrophysics PhDs who decided to move into the world of data science. Yeah.
So who's getting paid more?
Yeah, it's a great question. I don't have any data, so I can't give you an honest answer there.
Who's getting paid more? It's which job is easiest to get?
It totally depends on your skill set, right? So I think like the point of this is, like if you're looking for a job, then kind of think about like where you are on this 2x2. Like, are you, super amazing software engineer and you're just starting to learn machine learning, or are you an amazing machine learning researcher and you've like never worked with a production code base in your life? And then also think about what skills would you actually like to develop? Yeah. So like for me, it would be easier to get a job as a machine learning researcher, but if I had worked as a software engineer for 5 years instead of working on a PhD, then maybe it would be easier to get the ML DevOps job. Okay, I want to say a few words about machine learning team structures. So the consensus here from the folks that we talked to is that there is no consensus. There does not seem to be a right answer right now in terms of what the best way is to structure machine learning teams. And so what I want to give you a sense of is like what are some of the different choices that people have made. So one thing that most people believe is that it's important to have a mixture of software engineering skills and machine learning skills coexisting within the same team. And a lot of people that we talk to also feel that everyone on the team needs some level of software engineering skills. So like just because you have a machine learning PhD from Berkeley, doesn't mean that you would have an excuse on these folks' teams for not being able to write good production-ready code. One place where people have very differing views in general is on the role of machine learning researchers on their teams. So some folks think, machine learning engineers, they seem really smart, but it's just too hard to make them work well together with engineers. And so I'd rather have a bunch of people who can work on engineering problems together, even if they know less about ML. Other people that we talked to said that having really deep expertise on the team is super necessary in order to being able to move fast, because these people have like stepped on all the mines in the minefield before, and they know, and they're able to help the team navigate around some common problems. There's also a pretty wide range of views on data engineering. In some organizations, this sits within the ML team, and the argument there is that since the machine learning team is the main customer of the data engineer should just sit with that team and make sure that they're building exactly what they need. Other organizations think it should be a separate team. And some people that we talk to think that it's actually really important to have a data labeling team in-house that's dedicated. And these folks aren't necessarily doing the labeling themselves, but they're building tools to make the labeling process go faster. Yes?
So where do data scientists with domain expertise come in? In our case, we're in construction, and we have data scientists that also have PhDs in civil engineering and construction, so they can actually help kind of effectively be more effective models in a sense. And I'll see anything in your descriptions there.
Yeah, so the question is, where do data scientists with domain expertise come in? I want to turn that question around to you. Like, what have you seen to work best in terms of integrating those folks with machine learning teams?
We get much more throughput from better understanding of what should we look for, what are typical feature sets.
Yeah.
We get a much better understanding of what the state of the art is on the construction of things, so then we can actually try and see, okay, can we answer it with data. So in a sense, I would say it depends. Practically similar like practice. You need domain experts to be able to guide you through the medical records so you can understand what's in there, or images or so.
Yeah, so the answer was, it's for your team, it's super critical to have domain experts because they can help you navigate, some specific parts of the data and the problem that you wouldn't see if you just knew about machine learning. And that's definitely something we've heard from a lot of folks. You mentioned the medical industry. I think that's like particularly true there. And then I think there's also a different class of people who kind of believe that as long as you're the smartest software engineers and researchers in the room, then you should be able to solve the problem with that alone. It's kind of like a Silicon Valley mindset that, decide for yourself whether you agree with it, but that's a different viewpoint that we've heard. Yes?
Just a comment on that topic. I think what our department we found useful is to have domain experts help create really good data sets, curate data sets, and then sort of transition it over to the ML experts who may not necessarily be as key.
Yeah, it's a great point. So the comment was, a really good way of doing this is to have domain experts involved in data set creation. And then once you have a really good data set, hand it off to machine learning teams. I think that seems like a very good way of doing it. I think one pitfall there is data set creation is not like a discrete task. Your data set is going to continually evolve as you learn what the hard parts of the problem are from a machine learning perspective. And so I think if you go down that route, then it's important to make sure that you still have access to those experts later. Yes?
We also found important to have SME subject matter experts to actually validate the machine learning model, because they usually have some unique perspective how to actually estimate the quality of the results.
Yeah, so subject matter experts are great for validating the results of your model and making sure that they work as well as you would expect. Okay, another thing that we heard pretty frequently here is that it's very, very hard to manage machine learning teams right now. And I wanted to point out a few things that we heard about what makes this so hard. And so the first thing is that it can be very hard to tell in advance how hard or easy something is. And these are some slides from a blog post that one of our guest lecturers, Lucas, put together. But this is about like kind of a project that he worked on where it was a Kaggle competition and many teams were competing on this data set. And this is what the accuracy of the best models that the team submitted looked like over the first week. So huge improvement from the first day until the 7th day. But then if you look at this over the first few months, then you see that actually almost all the improvement happened within the first week, right? And so and it's not because of lack of effort, because the number of participating teams was kind of growing exponentially as the competition went on. And so I think like the implication of this chart is that even if you have some really early signal in a project, it can be it's very dangerous to extrapolate from that and assume that that means that you're going to be able to do much, much better. And in general, like just knowing whether something is a hard machine learning problem or an easy machine learning problem requires a lot of experience, and both with the domain and with machine learning. Another challenge is that progress on projects in machine learning is highly nonlinear, right? So it's super common for machine learning projects to stall for weeks at a time, right? And like in a typical software engineering environment, that might be totally unacceptable, but for machine learning, especially machine learning that tends more towards research, it's just kind of a fact that this happens. And it's also can be very difficult to do project planning because it's unclear which ideas will work. And so planning timelines is difficult, and it can also be difficult to parallelize work among teams because especially in early stages of projects, there's often just a bunch of ideas that need to be tried. And so a different way of saying this is that even production ML is still somewhere between research and engineering. And so that leads to a lot of challenges. And related to that, like if you do have this interdisciplinary team that combines research and engineering, a lot of people mention that there can be cultural gaps between those two worlds. So academic culture has different values. People have different backgrounds, different goals. Are they trying to publish or are they trying to ship code? Different norms about how to work together. And in some cultures, those two sides kind of don't really see eye to eye, and in the worst case, it seems like they often don't actually really value one another. So this is another pitfall for running teams like this. And then lastly, I would say, because of all these things, it's a pretty common scenario that we heard from people is that actually sometimes leaders in the organization don't really understand all of these realities, and so leaders can kind of often try to force a framework or a way of solving problems that works for regular software engineering, but doesn't really translate very well to machine learning engineering. And so I don't really have I don't have the magic bullet for how to solve all these problems, but I wanted to kind of flag them as things that we heard frequently about what makes it challenging to get work done as a team that's building a machine learning product. All right, next topic is the hiring process. And so the first question is where should I go to look for machine learning and data science jobs? And this is relatively similar to where you go look for any other software engineering job. But the one thing I wanted to flag, or two things I wanted to flag here are the first technique here, which is applying directly to companies. I think a lot of people will tell you for software engineering this doesn't really work because these companies just get so much noise. But because of the talent gap for machine learning jobs, just applying directly to companies that you want to work at has a higher success rate than you might think. And then the other thing I wanted to flag was, one of the things that we would like to do with this course is help people who want to get jobs find jobs. And so if that's something that you're interested in, then come talk to the sponsors that are coming to this bootcamp, and keep an eye on the jobs channel, where even after the bootcamp, people will be posting jobs. And if you want to talk more about this or you want more advice on this, then feel free to message me, and I'm happy to chat about it. I think so. In terms of the interview process itself, software engineering interviews have become this pretty well-defined loop, and you can go buy a book on software engineering interviews and do a pretty good job of preparing yourself for what to expect. Machine learning interviews are less well-defined at this point, and so you do see the typical software engineering, whiteboard coding, pair coding, and things like that, math puzzles. But there are some things that are specific to machine learning interviews. So we've seen several companies that do pair debugging of ML code. It's pretty frequent to see take-home machine learning projects. So fit this model in this data set and tell us how well, and show us how well you do. And machine learning theory and linear algebra puzzles are also pretty common. And so, in terms of how to prepare for this, again, not that different than how you'd prepare for a software engineering interview. But I think the thing that you might also want to do is think about, make sure that you're really solid on ML fundamentals. I don't think most companies will expect you to know, the details of some crazy new architecture that was released 3 months ago. But they will definitely expect you to know what the bias variance trade-off is, for example. And they'll want you to be able to explain, if your loss is going up instead of down, what are some potential causes of that? And that kind of transitions into the last topic, which is the exam for the course. And the exam is really designed to help you prepare for machine learning engineering interviews. So the sole purpose of this is to be a resource for you all. And so you can take it on your own time. We'll release it after the course ends. And the questions are meant to be somewhat representative of the types of questions that you would see in a machine learning engineering interview. And so these are questions like, why, if you have a resonant architecture, what is the residual block actually doing? Why does this help eliminate vanishing gradients? Or a less theory-oriented question, suppose that you see this really noisy learning curve. Which of the following things could be the causes? And then a final example question could be something like, if for each of the following tasks, what loss functions might make sense for this task? OK, that's all I wanted to cover. And we have a couple, 1 or 2 minutes for questions. Yeah.
Will you release the answers for the exam?
It's a good question. We do let you take the exam as many times as you want to. So, yeah. Yes.
I was wondering if, in your experience, if you saw any kind of similar trends that you put in the chart with the data science assembly.
Is the question?
Like their backgrounds.
I see. For ML team managers.
Ideal situations versus your experience.
So is the question like, what are typical backgrounds for machine learning team managers?
Yeah, optimal ones.
Optimal ones. Great question. Well, it's someone who's an amazing machine learning researcher and amazing machine learning engineer and has tons of management experience and is super familiar with the domain. I mean, look, I think the reality is that there's just a lot of variability now. Some transition from like engineering management roles and then sort of gradually focus on managing more machine learning type teams. Some are, machine learning people who, eventually move from individual contributor roles to management. There's no real rule for it, I think. Yeah.
Is it recommended to have people with expertise in more classical approaches to machine learning on team?
Is it recommended to have people with expertise in more classical approaches? I think it depends on what problem you're working on. Yeah, I mean, like for example, if you're working on image classification, it would certainly be helpful to try some classical things, but I think the reality is that deep learning is going to work much better very quickly. But I'm sure there are problem domains where it makes sense to have very, very good classical machine learning baselines. Yeah, I'll take one last question.
If you see most of the job requirement, they ask for you have to have big data background, you have to deploy the model, you have to have deep learning, you have to have machine learning. So a lot of requirements for a big time. So and then you categorize to data engineer, and so I don't know why they ask a lot.
Yeah, I think I don't know. I feel like I've seen job posts where they're like, yeah, you must have like 12 years of TensorFlow experience, and I'm like, wait a minute. I don't know. I think I started using TensorFlow like right when it came out, but yeah, I think like actually this is an important point, but I think a lot of times, well, this is true for job postings in general, and I think it's especially true for machine learning job postings, but they're kind of aspirational. So if you meet some of the requirements and not all of them, I think it's like still reasonable to shoot for it. All right, great. That's all we have time for.